in this video. Hello everybody and welcome to the 31st video of the channel. It is another geometry lesson. And since last video was a proof of the Pythagorean theorem, today there's going to be no answers to our previous questions. This is the start of our proof series where I'm going to show you proofs, not really proofs, but I'm going to show you theorems and formulas, and then give you practice problems, and then do examples and give you practice problems. Soon, as it gets more and more advanced, there will be more theorems and more proofs, but for now, we're just going to stick with what we have here. One more thing before we go on to the lesson, please make sure to like and subscribe for more awesome content just like this. Without further ado, let's go on to the lesson. Today's lesson is about a few angle theorems. These are the corresponding, wrong spelling, not corresponding, corresponding, which I am not spelling right now, corresponding angle theorem and alternate angle theorem. Alright, so after that, these are the two theorems I'm about to explain. So, the theorem starts is if we have two parallel lines, and by the way, these have to be parallel, and if a transversal or another line just comes and intersects it. Now that will create 8 different angles across the two lines and their intersections. I have those 8 angles labeled. Now, if I remove the 7 real quick, put this here, we see all the angles that have this symbol on them, and since they're only one arc, these are all the same. And these are a result of the theorem. If we quickly erase all the numbers and then just focus on the theorem, it'll become clear. So, let's start with the corresponding theorem, the corresponding angle theorem. Corresponding angle means that if I have two parallel lines, it kind of creates a quadrant. Well, no, the parallel lines don't create a quadrant, but the intersection kind of create 4 parts. And those parts can have angles. But there's top right, top left, and bottom right. So, if we have top right and top left, then we have top right and top right for the different quadrants, in quotations. Those angles are equal. Same with bottom left, top right, and top left. Top right, bottom left, bottom right, top left. All those, that's why it's called corresponding. Alright? Then, after that, alternate exterior or alternate interior, both of those theorems, I should probably just say alternate exterior / interior. And I would also like to add a third theorem, although I think you guys probably should know this. But even if you don't, the opposite angle theorem. So opposite. All these angle theorems. So I'm just going to draw lines to show that these are different theorems. So if we erase this and redraw it, where we have our lines again, our opposite angle theorem is where we have different quadrants, top right, bottom left, or top left, bottom right. Those are opposite angles, and those are the exact same. Now for the alternate interior / exterior angles. So, the interior angles are the 4 angles that fall within the lines. So, basically the angles, if the 1, 2, 3, 4, 5, and 6, if you remember the 8 angle drawing. And the exterior angle are 1, 2, and 7, and 8. So make sure you memorize that. Even if you don't do it exactly like that, the 1, 2, 3, 4, 5, 6, 7, 8, just make sure you remember the interior angles and the exterior angles. Now, the reason it's alternate is because it's on the opposite side. One's on the top, one's on the bottom. and they're on opposite sides of the transversal or the line that intersects both of the parallel lines. So what I mean is this angle and this angle, the ones which I put the arcs on, are the exact same. This angle, one with the double arcs, this angle, the other one with the double arcs, are also the exact same, or they're equal, or congruent, as in geometry it's called. So, that's the alternate interior angle theorem. The alternate exterior angle theorem is simple. It's just the same thing, except they're on the outside. Except we have the angles on the outside and on the opposite sides of the transversal and on the opposite lines. So let's move on to some examples. Alright, today we have two examples. Both of these examples involve finding an unknown angle called x. Now we have one given angle, and we're assuming both of the lines are parallel. These two lines are parallel, and then we have a line intersecting them, thus creating the A angles. So, for our first example, we have 37 degrees as our given, and we want to find x. So, we have to find a way to get to x. But if you look at what are the similarities. Number one, they're both on the outside. So, that could be a sign that we could use the alternate exterior angle theorem. But we have to check to make sure it's on opposite sides. So, let's look at it. Alright, this is on the right side and the x is on the left side. So that is correct. We could use the alternate exterior angle to conclude that x is equal to 37 degrees. Because the alternate exterior angles, corresponding angles, alternate interior angles, and opposite angles are all the exact same. Alright, let's go to the second example. Now, as we see here, it looks like they're on opposite sides, but one's on the outside, one's on the inside. So it's not corresponding. So it's basically none of them. So there's no direct theorem, but we can find a way to get to it. Now, if you realize that one line, the angle that formed is 180 degrees, and if a line intersects that, it just splits into two angles that add up to 180 degrees. So, if we look at this, then this angle is equal to 180 minus x. So, but as you see, these are corresponding angles. So 50 is equal to 180 minus x. If we solve this like a simple algebra equation, we get x is equal to 130 degrees, and that's our answer. Let's move on to our practice problem. For today, we have two practice problems. And, of course, the first one is the diagram. The second one is also the diagram that is right on the side of it. And, we have to find x using different theorems. So, just so you know that all of these are the same time as above. And, of course, none of our lessons are complete. Make sure to like, subscribe, and hit that notification bell for more awesome videos. Because if you haven't already, I really hope you do. Thank you so much. See you in the next one, and bye-bye.